two, 1 2 1 2, 1 2 1 1 2 2 2 1 2.
Or use it in insert.
Yeah. So I should use it as a channel.
Yeah, as a channel.
Okay.
Any channel. Wait, is that line? I think it's more for okay, let's try line actually. If there's a line.
Hello.
Oh yes.
Testing sound. Test sound.
Simulate a mic
1 1.
Let's now. This one.
Yes.
This one.
Yes.
But this one is good though.
Oh, this one's good.
Yeah,
Yeah,
I
that
think
one's good.
yeah. So
We won't have a problem with the team.
Testing. Yeah, so I didn't have breakfast today, guys. Testing. Testing. Mic, 1, 2, testing. Is it fine? Should I still mute?
Say again? That includes questions, right? Okay, that's fine. No, you can start with the introduction. Okay, two. Whatever. Come to your WhatsApp, right? Is it better? We start.
Good morning,
Good morning,
everyone.
everyone.
Good
Good
morning.
morning.
Do we need
Do
to
we
still
need to
wake up?
still wake up?
My name is
My name
Bonolo
is Bonolo
Mraka,
Mraka,
and
and
I will be
I will
taking
be
you
taking
through
you
the order
through
of
the
the
order
day
of the day
today.
today.
Um,
Um,
we will be
we will
starting
be
off
starting off
with
with
Prof. Mpego
Prof. Mbeko
Online,
Online,
and then
and
we
then
also
we
have
also
Miss
have Miss
Kimikas.
Kimikas.
Um,
Um,
so,
so,
the event of
the event
today
of
is
today
the
is the
roadmap
roadmap
from lab
from
to
lab to
market,
market,
and we
and
will
we
be
will
going
be
through
going
the
through the
science of
science of
secure
secure
data beyond
data
the
beyond
hype.
the hype.
Uh,
Uh,
So we're
So
trying to
we're
bridge
trying to
the
bridge
gap
the gap
between
between
innovation and
innovation and
commercial
commercial
success.
success.
Um,
Um,
our
our
first
first
guest
guest
is
is
Prof.
Prof.
Mbekwa.
Mbego.
Prof. Mbekwa
Prof.
is an
Mbego is an
associate
associate
professor
professor
at the Institute for Sustainability and Corporate Citizenship at the University of South Africa and NRFY rated researcher. She has 23 years of combined experience in industry and academia. I'm not sure if maybe any one of you did any computer science modules Is there anyone in here who did any comp sci modules? Because you would be familiar with her. She was with us at UJ. So she, as I mentioned, she has 23 years of combined experience in industry and academia, including 17 years in academia and over 8 years in management roles, which have shaped her expertise as a cybersecurity specialist. So in academia, she has worked at several universities in South Africa, including the Walter Sisulu University of Mpumalanga, University of Johannesburg, and University of South Africa. She has taught modules such as information security, informatics, and communication networks. These academic roles have further strengthened her expertise and leadership in the field. So Prof. Mpego is with us online. You will be able to see from the projector as and when she presents. So without any further ado, let us hand it over to Prof. Morning, Prof.
Good morning, Bonolo.
You can go ahead with your presentation, Prof.
Okay, went muted once you started. I don't know what happened, but let me share my screen and you'll let me know.
Okay.
Okay, can you see my screen?
Yes.
Bonolo, can you confirm?
Yes, Prof. We can see your screen.
Okay. I don't have to show my face or anything, because I can't see anything on your side, what's happening. So must I show my face?
You can just show your face so they can know who they are with.
Okay, I'm not sure if I'm audible, but I'm assuming I am, and you can also see my face. Good morning, everyone. I hope you're well, and I'm hoping it's going to be a great session for you, and because we've been waiting since 9 o'clock for you guys to arrive. So we are here, and we're hoping that you're going to learn a lot. So I'm going to switch off just so that we don't have any bandwidth issues. But if you want me to switch it on, you can let me, you'll allow me and let me know that you want me to continue in that fashion. So thank you so much, Bonolo, for the introductions. I only heard the half part of it, and then we got disconnected. But anyway, as Bonolo have mentioned, I am Noluntu Mbegwa. I am currently an associate professor at the Institute for Sustainability and Corporate Citizenship at UNISA. I was given a task that I must present on secure data to you, and I was given a topic as stated there in my slides, the science of secure data beyond the hype, and of the mandate. So the table of content, these are the 3 subtopics that actually was given. The first one is the garbage in and garbage out problem. Here we'll be looking at approaches to ensuring that only verified and trustworthy data enters data storage. And then the second one is the auditor's eye. Here we'll be talking about ways one can identify and address security flaws in their project before deployment. And then we will conclude by talking data integrity. We will be talking the secure identity and provenance systems using sound IT principles. So to get straight into it, I thought this will be very important to start with this slide so that we kickstart this conversation or this presentation on the same level understanding and same ground. I'm sure you will agree with me that in 2026, in this digital space that we're in, that we can say data is the new currency. Now, we mean any kind of data, personal data, any other data is the new currency. So people are looking for that data. People want that data for various reasons. So hence we say data is currency. So it's quite important that we protect this data because we use this data for processing. We use this data for decision making. We use this data for recommendations and for forecasting for different systems. So this data is quite valuable. So it's important to actually begin this conversation and this presentation on that footnote to say this data is important. And I'm sure you will agree with me, regardless of the data itself, whether, as I said, is personal data or any kind of data, it is important. That's the whole point. Now, moving into the first topic, which is the garbage in and garbage out problem. I thought, let me look for a nice picture that can depict exactly what happens when we're talking about this. So if you look into this slide, on your far left, you see the garbage in. Here we're talking about poor input data. That includes errors and inaccuracies, missing values, and biased information. That sends into the processing. It doesn't matter what kind of system, as long as it's a system that processes that data. The system, the only function it does is to process the data. It does not do anything beyond but process. So if you put any garbage in, obviously what you will get out is the same, which is garbage out, which is flawed output. That means wrong analysis, bad prediction, and faulty reports. But we don't want that, right? So we need to find ways to say, how do we ensure that we don't have garbage in and garbage out as a problem? Now, to prevent the garbage in and garbage out problem, organizations, developers, etc., must implement strong data quality controls, such as your automated validation, your standardized data contracts, your continuous monitoring, to ensure only verified and trustworthy data enters your storage. These measures, they actually reduce your errors, improve reliability, and safeguard decision-making process. So what are those measures that you can look into? So you can use approaches such as data validation and cleaning. In this approach, we're looking at a number of options. For example, automated validation roles. Here, you check for missing values. You are checking for duplicates, incorrect formats, and out-of-range entries before data is stored. So this is what you do before you can actually store the data. You can look at standardization. Here, you ensure consistent units, the formats, and the naming conversion. For example, converting into Celsius, so that all the data is consistent and talks the same conversion. Deduplication, remove redundant records, and you avoid skewed analysis. And then the last one is error correction. You can use algorithm to detect anomalies as well as flag suspicious entries for review. You also have another approach that you can look at data contracts and guide rails. Data contracts means you must have formal agreements between the producers and the consumers of the data that define the schema, the quality expectation, and the validation roles. So if you are not the one collecting the data or providing the data and someone else is doing that, perhaps then you must look into the data contract. You hear a lot about this when you are in the industry, and perhaps you are just a developer, someone else is doing the data collection and provides the data to you. And then the second one is the guide rails, automated checks that enforce these contracts at scale preventing bad data from entering the pipelines. So you automate what is in the contract and applying the rules that were in the contract to ensure that that data meets the quality that is expected. Governance framework establish accountability and ownership of data quality across the teams. So this is quite important. There must be someone who takes accountability, and there must be someone who will take ownership of that data. So that there must be someone who takes to say, if something is wrong in this particular data, who do we consult? Who do we talk to so that we can fix the problem? Another approach is metadata and provenance tracking. Here we talk about source verification. Here you record where data originates. Where does this data actually comes from? And this is quite important because where data comes from, it will also determine the level of trust that you're gonna have for where it comes from. For example, when you are collecting your data from particular participants, because you have interviewed them or you collected yourself, then you know that you were collecting from the actual people. But if you collect data from a social media platform, you might not have high levels of trust when it comes to that kind of data. So it's important to separate, to say, where does that data actually comes from and how it was collected? And also if there was any transformation that was applied into that data. Similarly, audit trails are very important. That enable traceability to detect when and where errors were introduced. And then lastly is confidence scoring. It assigns trust levels, as I said, as I was talking about where the data comes from. You assign trust levels to each data to say, how much trust do I have for this particular data? How much trust? So that you know how you handle it and how much you make decisions out of that kind of data. It is reliable or not. The next approach is human oversight and stewardship. Data stewards, they assign individuals that are responsible for monitoring and enforcing data quality standards. Remember, I mentioned it in the previous slides that there needs to be ownership of this data as well as stewards. So we need to have data stewards that actually then their responsibility is only to monitor this data and ensure that they enforce standards for data quality. Because we have data stewards and data owners, therefore training is needed. Perhaps when you go to the industry again, these are some of the terms that you're gonna hear when they talk about that. You need to attend training. So here we educate staff on proper data entry practices to reduce human error, all right? Because this data is quite very important. And if there's any error in this data, as we said, then there's gonna be errors in terms of our prediction, there's gonna be errors in terms of our recommendation. So it's quite crucial that anyone who's part of this process understands that this data needs to be correct so that we can get correct predictions. Feedback loops, they allow users to report inaccuracies and continue their data sets. Continuous monitoring and quality metrics. One can have dashboards that track data quality KPIs. These are important, such as your completeness. How complete is a particular row in a database? That one record, how complete is it? Accuracy, how accurate is it? Can we trust it that it is accurate and it will assist in us making recommendation? Timeliness and consistency. Consistency is important. For example, when you fill a form and we'll say date of birth, sometimes it does not give you indication whether when you fill in the date of birth, you start with the year, the month, and the date, or you don't know if you're gonna start with the date and the month and the year. So imagine if the input is not controlled and managed to say, how do you insert this date of birth? All of us will insert it in different ways and it will be inconsistent. And then, of course, it will process it differently and it will give incorrect recommendation at the end. So that's where the consistency is important. Alerts, they notify teams when anomalies or violations occur, and then also use of machine learning models to detect subtle patterns of corruption or fraud in real time. What are the risks of garbage in and garbage out if they are ignored? One, you can have faulty analytics. I think I've mentioned that. This means that you can have misleading insights leading to poor business decisions. You do not want to find yourself having to be called by the CEO of a huge business because your solution or your system has given a bad prediction or has landed the business making a poor business decision. Secondly, AI model failure. Machine learning systems trained on bad data, they produce unreliable predictions. So even how good your model is working and how good it is combining all this data, as long as that data is bad, it's going to produce unreliable predictions. Compliance issues, regulatory fines, if inaccurate, you could face that, or unverifiable data is used. So you do not want to find yourself not being compliant again. Loss of trust is the worst of them all. Stakeholders lose confidence in data-driven systems. If they don't work and then they don't predict the way we expect them, then people don't trust it. Then moving to the second component of our presentation, which is the auditor's eye. Here, you are looking at a mindset that one can adopt to critically examine their projects for security flaws before deployment. It's about thinking like an auditor, questioning assumptions, testing boundaries, and verifying that every component actually behaves as intended under real world conditions. Now, what can you do here? You can perform threat modeling. You ask what could go wrong. For each part of your system, you look at the input part, question each and every section of the input. You look at data storage, same question, what could go wrong? And then APIs and user interaction. I'm sure by now you've heard in terms of security that humans, we are the weakest links. Now, everywhere where you see a user coming in, you must always think where a user is the weakest link and can be manipulated. So always think that the user is easy to manipulate and which measures can assist you then to ensure that there's another level and layer of protection. So you can use frameworks. There's a number of frameworks that you can get, but the most popular one includes the STRIDE framework: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. So for each of those parts, input, processing, and output, and user, you apply STRIDE to say, where can spoofing happen? Where can tampering happen? Where can repudiation happen? Where can information disclosure happen? To each and every section. Yes, it is a long process, but after you've done this, you will be confident that you have looked at the whole entire system 360 degree. An example here in a student web app, consider how an attacker might manipulate form inputs or even intercept that data. Now, what is important again is document potential attack vectors and how you're going to mitigate them. and then you implement those mitigations. Another way of doing is to conduct code reviews. You review your code with peers to catch insecure practices such as hard-coded credentials or unvalidated inputs. You can use different tools that are available, static analysis tools to automatically flag vulnerabilities. Also, you can encourage a no-blame culture within the team, because the minute you start blaming each other, then it's going to be difficult to continue working moving forward. So it's important that you find errors together, you fix them together, so that you can focus on improving security and not pointing fingers. Again, you can also apply secure coding principles, including validating all inputs to prevent injection attacks, use parameterized queries instead of string concatenation for database operation, encrypt sensitive data both in transit and at rest. Some of these principles and also measures that I'm going to mention can be very technical. So it is always suggested that when you put together a team, particularly in industry, you'll realize that a team can only be a team if you're going to have a security person, an AI person, a mobile developer, and so on. So you come together and then you all share this expertise. So if you have a security person in the team, then they will come and say, how do you actually implement all these principles and all these measures that are technical in terms of security. An example here would be when building a login system, instead of storing the password in plain text, one can use hash to actually hash the passwords using different algorithms, so that even if an attacker attacks the database, where at rest the data is not in plain text, it is not easy for them to actually see the password. Test like an attacker. In fact, it should be saying think like an attacker. It's important that you must always think like an attacker, because that's when now you will start having an eye in terms of your project that you are working on. So here you need to run penetration tests using different tools. I know Burp Suite is the most popular tool that one can use that actually can simulate these attacks on your application or on your solution. Also try fuzz testing. This is quite important, and usually I found while I was at UJ, some of my students were not familiar with this. You do not only test your solution in terms of the correct information, all right? Also test using malformed data and feeding random responses that are unexpected. That's us humans, right? We put things like, how did you think about that? How did you get there? So think about feeding it random malformed data to see how then the system will react with that kind of data. You also simulate common attacks like your SQL injection, etc., and check for default configuration that exposes unnecessary ports or services in your system. Secure dependencies and libraries. This is very, very important, because if you trace back most of the attacks that you've seen, we have a number of attacks, like I think 2 weeks back, I think Standard Bank was attacked, many other attacks, even last year moving back. You will realize that if you read further on them or follow them, most of these attacks are because of third-party packages that we do not clean up and always check on them and always update them. Once that third-party package is, it has a ROM that they can be used, they use that, attackers, they use that to actually get into your system. So not that your system is not protected, but because you are linking or there's a plug-in to a third party, so they use that third party. So regularly update third-party packages and frameworks. Use dependency scanners to detect known vulnerabilities and avoid downloading code from unverified sources and stick to official repositories. Implement access controls. This helps with that issue that I've mentioned, that humans are the weakest link. We need to make sure that we understand that and implement measures. Humans, even you as yourself, you are a weakest link. I'm sorry to say it, but it is true. We are the weakest link. So we need to always put measures to protect that problem. So apply the principle of least privilege. So meaning give users and processes only permission to what they need. Even you as a team in your project, you must understand that you gonna have different responsibilities in terms of your project. You're gonna have different access to different information, whether in GitHub or in the system itself. So it's important that you apply those principles of least privilege so that only certain people can have access to what they need. Use role-based access control for clarity and scalability. Again, here it uses the group project. Ensure only admins can modify system settings. You don't want everyone having that access to system settings. Today is this and tomorrow someone else comes and changes it. Document and monitor. Keep a security checklist for every deployment. You must also log system events and monitor for unusual activity. There are systems that you can use for that. Document how data is handled, stored, and protected. This will eventually help you during audits or peer reviews. Document all changes and patches. I know sometimes documenting seems to be like an admin process. It's not technical. Why should I be documenting? It's quite very important, because should anything happen and you want to go back to understand what did I do and how did I get there, those documents will be your first point of departure. Ensure secure deployment settings, your firewalls, your HTTP certificates, etc. Those are the things that you need to look into. Adopting the auditor's eye means treating your own project like someone else's system. So it means you need to find a way to remove yourself as a developer so that you think that this is someone else's project, and so that you can be able to say, how can I break into this? But if you want to protect it now and you don't want to solve, then you're gonna think like, no, this is my system and it's 100%. It's not gonna help. So by combining curiosity with discipline, meaning testing, documenting, and validating, you'll not only secure your project, but also develop professional grade habits that actually employers are looking for. So I've listed a number of scenarios here. One common flaw you can find in the scenario and a practical way of fixing it. It could work, or maybe you can find another way to fix it. For example, if you have a web app project, a common issue there, you can have unvalidated user input, which is, as I said, very common. How to fix it? Here you validate and sanitize your input by having a server side that can do the validation and sanitization. Mobile app, you have common here, storing passwords locally. Here, the solution could be use secure token-based authentication that can try and resolve that problem. A scenario, you can have IoT prototype. Most of the time, we find open network ports that are not even being used. So they can be used as by an attacker to actually enter into the system. Here, what you can do is restrict access and enable firewall rules. And of course, you close ports that you don't use. Group project, this is so common. The group, all of you, you are 4 or 5. You think that it's important that all of you must have admin credentials, but now you have one shared admin credentials. Now, if there's 5 of you and you are using the same admin credentials, it means you are unable to track who logged in, what time they logged in, and what changes they've made, because all of you have the same credentials. So please avoid that. Implement individual accounts and password policies. Now, you need to think like an attacker, but act like a guardian. So the auditor's eyes isn't about paranoia. It is basically about proactive awareness, being aware what could be the problem. It's like being in your own house. You have your house, like, okay, fine, I have a window, but I don't have buckler that protects someone from coming in. So it's not a paranoia. It's possible that someone can enter through the window. They can break the window and come in. So it's just being aware to say, what can I do to ensure that no one enters through the window? So every project, no matter how small it is, benefits from a security first mindset. Moving to data integrity. Data integrity, again, is just not an IT concept. It's a habit. By combining technical safeguards with governance discipline, one can ensure that projects produce reliable, verifiable results that stand up to scrutiny. So that's what we want, and that's what we're looking for. So data integrity ensures that information remains accurate, consistent, and trustworthy throughout its life cycle. It's the foundation of secure identity and provenance systems. Systems that verify who created data, when, and how it's been changed. Now, there are certain principles that you can look into in terms of IT governance. The first principle is accountability. Here you can assign clear roles for data entry and review. And again, for implementing this principle, one student can manage data input and another one can verify accuracy. In that way, then we can ensure that that data entry that was done is accurate and is correct. Transparency, document all data sources and changes. For transparency, meaning you want everyone to have the same data and see all the changes. So we use any cloud shareable storage that everyone can access. And most popular is GitHub. So it keeps version logs or change log so that everyone has access to that. So it provides transparency. Integrity, you can use checksums or hashes to detect tampering. Integrity means that as I share this information, it lives here where I'm sitting and it goes to Munolo. It must arrive exactly as it is. So we use encryption. It doesn't matter which kind of encryption, depending on the level of importance of the data, just to make sure that that data, as it is being transmitted, it arrives as it was. Compliance, you follow ethical and privacy standards. Again, there's many standards, and it depends what kind of data you are talking about. If you are talking about private information in South Africa, you'll be talking about POPIA. So, for example, if you're collecting data from participants, you can look at how to anonymize that data in your research project. If you are talking about health data, you are talking about HIPAA standard and things like that. So it's important that if you're talking about any data, go and find out, are there standards that actually govern how we collect this data, how we store this data, and how we process it, so that you understand the standard first, and then you try and apply that standard within your project. So other measures to ensure data integrity, secure identity systems using multiple factor authentication for access to sensitive data. Again, enforce least privilege, give users only the permissions they need, regularly audit access logs, meaning check who accessed what and when. And then also, I know we're so lazy when it comes to this, but rotate credentials, change passwords or API keys periodically so that it doesn't become a norm and people can guess your password at a certain point in time. Provenance, protect data provenance. Provenance tracks the origin and the evolution of that data, such as we record metadata, which include timestamps, authorship, and version history. We use digital signatures, as I said, digital signatures to protect that this data actually was sent by that particular person. So verifying that data hasn't been altered since the creation by that particular person, and maintain immutable logs, store audit trails in secure append-only systems, backup regularly. I'm sure also when you started your project earlier this year is one thing they've told you, that please back up your project because technology can fail us. And if you do not back it up, you might end up not having a project at all. So keep verified copies in multiple secure locations. Implement technical safeguards, encryption, which protects data in transit and at rest. Implement validation, check input formats, enforce schema rules. Monitoring, use dashboards or alerts into integrity violations. And recovery plans. As we said, you must have backup. Test the backups once in a while. See if you can restore data from those backup storage that you have. Cultivate a data integrity mindset. Again, I cannot overemphasize this. It's a mindset, and I know it's a lot that we've covered, but try and see if you can implement one thing at a time, and then make sure that it becomes part of your routine. And then it becomes your way of thinking from now on. So treat every data set as a trusted asset. I think I needed to highlight asset, because if you look at it, your data as an asset, it means it's valuable, it's important. Question sources before using them. Document every transformation or analysis step, and encourage peer review, meaning as a team, as a peer, each other, you must review each other's work. Don't be worried that you're gonna receive criticism, or you're gonna be criticized, or they're gonna find faults, but look at it as assisting you and giving you another pair of eyes that can actually catch errors quite early, which is important and what we are looking for at the moment. So at high level, we looked at garbage in, garbage out, which are ensuring quality data. And we also look at the auditor's eye, finding security flaws, and then data integrity, which looked at securing identity and provenance. So garbage in, garbage out, we looked at data quality, verification before storage. Our goal here is to prevent bad data from corrupting analysis or decisions. There were a number of approaches that we discussed, including validating and cleaning data before saving it, using standardized formats and schemas, apply data contracts and automated checks, track data provenance to ensure authenticity. Here, always question your inputs. Reliable results start with reliable data. In terms of the auditor's eye, The theme was looking at security awareness and flaw detection, flaw detection before deployment. The goal is to encourage proactive identification of vulnerabilities. Some of the approaches that we discuss is to perform threat modeling and peer code reviews, test like an attacker using fuzzing and penetration tools, secure dependencies and enforce least privilege. Importantly, document and monitor access and changes. The takeaway here is you need to think like an auditor, inspect, test, and verify before you trust. Data integrity, the theme was safeguarding identity and provenance through governance. The goal was to maintain trust, accuracy, accountability in data systems. Approaches that we talked about is applying IT governance principles such as accountability, transparency, and compliance. You can use encryption, hashing, and digital signatures. You can maintain audit trails and immutable logs, regularly backup and verify data source. Takeaway, protect the truth of your data. Integrity is the backbone of trust. Now together, these principles, they teach students to build systems that are clean, secure, and trustworthy from the moment data enters to the moment it is used or shared. So I hope I've covered in terms of your expectations, and yes, and I've answered perhaps most of your questions and things that you will perhaps wanted to know. Thank you so much for listening, and over to you, Bonolo.
Thank you so much, Prof.
So, I hope
you
you
took as much as you can
from what
Prof Mpeko shared with us. I saw most of you are not taking notes. You're just listening.
Are you sure
Are you sure you're going to remember the things that she mentioned?
Are you guys sure?
sure?
So is there any
questions for Prof before?
Is there any
Is there any questions for Prof?
No questions.
No questions.
You see, this is what happens.
You see, this is what happens when you just
You're
listen.
not taking
You're not
notes.
taking notes.
In fact, I can ask them a question then.
Okay,
Prof actually
wants
wants
to
to
ask
ask
you
you
a
a question.
I'll get your
I'll
question.
get your question as well.
To test if they were listening.
So she wants
to test
if everyone was
everyone was
listening.
listening.
So she's the
So
one
she's the one who's
going
going to now be asking a question.
You can go
You
ahead.
can go ahead and ask your question, Prof.
Okay. In terms of data, which data is important? Your pet's name, your identity number, your student number, or all of the above?
So in
So in terms of data, which one is important? Your pet's data, your ID number,
your
student number,
or all of
or all of the above?
Is
Is there a consensus?
Everyone is saying
Everyone
all
is
of the
saying all
above.
of the above.
She's giving everyone a thumbs up. Okay, thank you so much, Prof.
Bonolo, you are muted. I could not hear that.
So, Prof,
So, Prof, they said all of
above.
the above.
Okay, at least I think they were listening. So well done on that one.
Okay, thank you so much.
Thank you
Prof.
so much, Prof.
Thank you.
Oh, okay.
Oh,
There's
there's
a
a question actually.
Nasiru, you may ask.
Consider you may ask a question.
You're asking.
You're asking Prof, not me.
You can come here.
You can come here if you want. Okay, ask and then I'll reiterate.
Yeah, my question is, what happens if the data breach is not your? For example, what happens if something
And can we please have one class?
Okay, thank you. So my question is, what happens if the breach is not your fault as a developer? For example, Vessel got hacked in past days, I think 2 days back. So what happens if I have something on Vessel? How do I protect myself there when my main, how do I say, my parent got hacked? Now, me as a child, how do I protect myself there?
Will you be able to repeat that for me, Munolo? I did not get it.
So he was asking, what
What happens if
the
the
data breach
data breach is not your fault?
He
He made an example of if it's the parent machine that got hacked into and his information is in it, then what happens in that instance?
So I'm trying to get this right. Your information was in your parents' machine and the machine was hacked, and you are saying it's not your fault.
Okay,
Okay,
I don't think I've asked him to come closer.
I've asked him to come closer so that you can be able to get the question properly.
Hello, Prof. Can you hear me?
Hello, Prof. Can you hear me?
So my question is, what happens if the data breach is not your fault as a developer? For example, Vessel got hacked in past days. And I have deployed things on Vessel. How do I protect myself? Where I deployed my things, the platform was hacked. What happens now to my platform?
Okay, so remember, your platform is not in isolation. When you are developing your platform, you are not developing to work in isolation, or your platform is not separated from the device itself. There's hardware, there's software, which is your platform. They need to work together so that it gives the function that it needs. So you cannot develop your software in isolation from the hardware. You need to understand, for what hardware am I developing for, and what kind of challenges do I have? Hence, you see in the presentation, I talk about data at rest, meaning in the device, and data in transit as it moves from one device to the other, whether via internet, via emails, or via whatever. So you must always think that this data is needed, whether it's in your system and your system has, your server are protected, are safe, have measures. But remember, your server needs to talk to the users who are using this system. So you cannot develop in isolation. It is your job to look for the overall environment.
Okay.
Let me also ask a follow-up. So, with the Vessel issue, right? Reports have said that someone's projects, so there's a file called the .env, which stores secret codes, maybe your APIs and the likes. So the reports say hackers might have accessed those keys through Vessel, not through my platform. Right, so how do I protect myself there when the breach didn't happen on my app, but it happened where I deployed the app?
You see, I think this is the mindset that we want to train software developers, that you do not only focus on your app. If you still remember, again, in my presentation, I talked about humans as being the weak link. If you want Vessel to be the one using your app and your system, you must think about Vessel in your measurements that you are putting in place. You cannot think separate and say, as long as my app is safe and I've secured it, I'm fine. No, because someone in any IT system, there's a system, there's a technology, there's the person, all right? There's people and technology. So between people and technology, they need to work together to actually use this particular system. Separate in a separate part and removing the rest of the. So this is one combined ecosystem where it involves technology and people. Now you have to think about the people that are involved in the system. I'm sorry, I'm not giving you the answer that you are looking for. That is not your fault. It is your fault. And it is.
Thank you, Prof.
Thank you, Prof.
There's still another question, Prof.
Thank you very much, Prof, for your wonderful presentation. My question has to do with what you mentioned in your answer. How do you get that mindset shift amongst the developers to prioritize security when they are developing their apps, their IoT devices? What are the practical steps with which you can incentivize them to really not just focus on just developing, but also focusing on security, which might not be their focus. My second question is, in light of all of this vibe coding, you're quite aware of what happens in the advent of all the co-pilots, the cloud code, and all of that. So almost everybody is a developer now. Now the problem is they do not have understanding of the whole security principles and how they can protect their products, their programs, and the rest. So what advice do you have? What are your thoughts with the new advent of vibe coding, and how can people do better at protection? Thank you very much.
Thank you so much. Perhaps, Wunolo, if you can mute. I don't know. I think it was better when you muted. So to respond to, I think this whole presentation, although it was squashed into 1 hour, usually when I was still teaching at UJ, the information security module is the whole entire module where we talk about different things that you need to look into, and a part of that is CIA. I'm sure if you can Google it, it will tell you what CIA is: confidentiality, integrity, and authentication. Those are the key foundation that one needs to look into when you are talking about security. Again, looking at security, you must look at it from the technology perspective as well as from the people perspective, because those two, that's where they merge. You can never have technology on its own. Technology sitting there by itself is not going to do anything. So people use technology to get to where they want to be or to get what they are looking for. So there's a collision that happens between the technology and the people, and we need to understand that. So perhaps that's the mindset that you need to have as you move from this presentation, that I must remove this thing that I'm separating the technology from the humans. Technology by itself is nothing. Humans without technology, we've realized that we cannot do it. So we need to bring this together. So you need to understand that there's the technology part of it and there's the human. And we need to understand that there are weaknesses that are brought by the technology, the weaknesses that are brought by the humans. And what are those? So what will be specific to you is to say, what kind of system or application am I developing? Who are the stakeholders of this system? When I'm referring to users, who is it that I'm referring to? Am I referring to an admin person? Am I referring to the CFO? Am I referring to an IT person? who might have IT background. So you need to be able to describe your users, your stakeholders, so that you understand the level of awareness that they have in terms of security, so that also that informs what measures do you put in place to protect this data that this system is using through the humans. Okay, so I think that is the mindset. You need to practice it. You must always think that, and I always say that I've been through so many industries before moving to academia. And once you are in the industry, people have this tendency that we want to come up with a system. Those are the IT people. That's us, right? The developers. No, we're going to develop a system that will do A, B, C, D. But have you asked yourself if the users want that system? Do users? So at the end of the day, we are a service provider. Understand yourself as a service provider. As a service provider, you cannot just provide something that is not needed, that is not asked for. And you need to ask, how do you want it? So you are not developing solutions for you. You are developing solutions for the users, for them to use the system. So it's quite important that you separate yourself and what you think is needed and what they think is needed. So what you need to do is to sit and listen. What do users want? What do they need at this point in time? And how do I use technology to get to where they want to be? So as long as you understand that, you are just the means to the end. You are not the show. You are not the person that is key here. You are just assisting what the users want to get to where they want to be. So as long as you will develop systems that are contextual, diploma or a degree at university instead of going and doing AI at a short course for 6 weeks or for 8 weeks. That is very similar because it feels like, I would say, a microwave popcorns that pop up quickly and then they flop quickly. Is that the foundation that you get when you do a diploma or a degree, a formal qualification? It gives you background in terms of how do you actually develop a solution. It talks about when you are a programmer, it tells you how do you develop for C++, C# or Python or whatever. It tells you how the system thinks, the structures that you need to put in place, and therefore you are able to interpret a code that is written. Major difference between you who's doing a formal qualification and a person who did not. If you can go to AI and ask the AI to quickly do a calculator, you will be able to interpret that code and even see the problems before you can run the actual program. A person who did not go through that will take that code and think that that's a solution that can work. They cannot interpret, they cannot read and see where is wrong in that code. So for me, I think even if we do have AI and all of that, that you can use to quickly do a popcorn kind of a code, as long as you cannot interpret and see what is wrong with it and where there could be issues of security, then you are in big trouble, because that solution that you have might even be have flaws and you cannot even see them. So for me, that is how can you identify the things that are wrong in terms of what AI provides and gives to you. I hope I've answered your 2 questions. Over to you, Bonolo.
Thank you, Prof.
The
The questions were answered correctly and not necessarily correctly, but then the person who asked is satisfied with the answer. There's another question, if you don't mind coming closer.
Prof, can you hear me?
Yes, I can hear you.
Okay, I have a question here. Under the section where you were talking about auditing data, you mentioned something like data sanitization. What is it and what does that process entail?
Okay, data sanitization is actually quite a also long process, but essentially you are sanitizing, you are cleaning it, ensuring that it is at the level that you want so that you can process it. So you sanitize it in terms of ensuring that it has the right values, it has the right versions that you want, or format, if I may put it. So it captures what is needed so that it can be properly processed and then can assist then in terms of making proper recommendation, making proper predictions, and so on. So you sanitize it, you clean it up, making sure that it is in the right format that is needed.
Thank you, Prof.
Is there any other question for Prof? So we are good. Thank you so much for your time, Prof.
They don't have questions. I believe they've taken a lot from what you've said. So Prof. Becker was covering the garbage in, garbage out problem, whereby you master the approaches to ensuring only verified and high quality and trustworthy data enters your system storage. And then she also touched on the auditor's eye to say that a practical guide, which was a practical guide rather for students and researchers to identify, diagnose, and fix security vulnerabilities in their own project before you reach the deployment stage. And then she also touched on data integrity, which was the simple, actionable steps that you can take to protect identity and ensure that provenance using industry standard governance principles. So thank you so much for
your time. We appreciate your time.
We appreciate your time.
Thank you for the invite.
Okay. So we will be moving on to the lecture two of today's session, which will be led by Dr. Kim Lamont Mbauli. So Dr. Kim is a distinguished multidisciplinary scholar, a legal practitioner, and corporate strategist whose career is defined by the integration of scientific research with the complexities of intellectual property law. And she currently serves as the Deputy Director of the Innovation and Technology Transfer Office within the Directorate of Research and Innovation at TUT. In this capacity, she plays a pivotal role in bridging the gap between academic ingenuity and industrial commercialization, ensuring that technological advancements are protected, licensed, and transitioned into the global marketplace. So Dr. Lamont's academic journey reflects an extraordinary commitment to diverse fields of excellence. She earned a PhD in medicine, an MSc in medicine, and an honors in human biology between 2007 and 2012, and then recognizing the critical need for legal frameworks in the protection of innovation, she subsequently obtained a master's philosophy in intellectual property law in 2015 and a bachelor of law in 2015, and a Bachelor of Law from the University of South Africa in 2019. She's an admitted attorney of the High Court of South Africa, a credential that allows her to navigate the highly regulated intersection of technology and law. A dedicated mentor and public speaker, Dr. Lamont Mbauli is a leading voice in the Advancing Women in the Workplace AWW program, where she works to dismantle barriers for underrepresented professionals in high-stakes industries. Her presence today offers a unique perspective for graduating engineers on how to safeguard their the technical innovations and lead with a comprehensive understanding of the legal and commercial landscapes that define the modern engineering profession. So I'm hoping you can, from the introduction, you can hear the caliber of the speaker. So she will be focusing on strategic research translations, on how to bridge the valley of death between lab, prototypes, and scalable frameworks, navigating legal frameworks, whereby she'll be focusing on understanding the regulatory, intellectual property, and legal requirements for energy and technology startups, and then the lab to market roadmap, which is a step-by-step guide to preparing your innovation for the scrutiny rather of investors and industrial partners. This is to help with ensuring the roadmap from your lab to the market. So without any further ado, let's welcome Dr. Kim.
Thank you so much. Good morning, everyone. It's always nice to hear yourself introduced. I feel like I'm a whole new person.
So, Prof, are you going to stay for the presentation? I wonder if I should leave you on unmute, if I should leave my mic unmuted.
We're just waiting for the slides, and then we'll start from there. But maybe from a show of hands, how many people have products in the market, whether it's IT, blockchain, weave, whatever product you're selling? Do you have any products in the market? No, yes, no side hustles, no entrepreneurs? Oh, they don't want to disclose in public. Okay, because your professors are here, but we understand. Okay, so today, while we wait for the slides to go on, we're going to look at what the difference is between an invention and an innovation. We're going to look at a commercialization journey. Not only that, we're going to look at how we can potentially bridge the valley of death when it comes to entrepreneurship and getting products onto market. And we're also going to look at intellectual property as an asset. So with me, I'm accompanied by Mr. Thomas Gatle. He sits in the Office of Innovation and Tech Transfer at TUT. He is our innovation specialist. So if there's anything that I don't know, I'm going to pass it over to Thomas. Thomas, maybe you can stand so they can see you. Thank you. Okay, so this is the overview that we've already gone through, and then we kick straight into it. So there's a big difference between an invention and an innovation. So an invention is what you're probably doing at the moment. You go and read your textbook, you go and survey the literature, you find a gap in the literature, you then come up with a project and a hypothesis that's going to feed into the gap. Some of you have funding, whether it's from NRF, wherever your funding may be, MRC, wherever else you obtain your funding from, and then you try and close that gap in the market or within your research. So that's an invention. And innovation adds a bit more flair to the invention. So you have to have the invention, you have to have the knowledge, you have to be able to utilize the knowledge, but not only that, the knowledge must be able to provide you with a monetary output, right? The knowledge has to be something that is relevant in the market. It needs to have a unique position within the marketplace. It needs to be effective, and it needs to provide you with something different. So there's a translation of an invention to an innovation. And that innovation must have utility, must have applicability, and it is something that you then take into the marketplace for societal benefit and impact. But don't forget, you also want to make chankuras, right? So there must be money benefit at the end of the day as well. So intellectual property then provides us with a unique proposition. It provides us with a unique value proposition. So we'll use the example of a maize plant. So a maize plant, before you get the plant, you have to put the seed into the ground. That seed in the ground is your intellectual property. It's your thoughts from your mind that you've put onto the piece of paper that you've now looked at while doing your project. It becomes your invention, and you now want to translate it through the commercialization process into an innovation. So the seed is something you want to protect. It's your IP asset. Intellectual property can be protected via various means. So you can patent it, you can do a trademark, you can use a trade secret, and there's copyright and design as well. Today we'll focus predominantly on patents, and we'll also look a little bit at trade secrets. But once you've planted the seed, you then have the growth of the maize plant in itself. So that maize plant then looks at what product can I derive from this particular seed. How can I utilize my intellectual property so that it is of benefit not only to myself, but that it's of benefit to society as well. And then the third part, from that maize plant, you get various different products. You get food from it, you can get biofuels from it. So the third engine that you're looking at is what is the socio-economic return? How am I making money from the product that's going to go onto the marketplace? So intellectual property definitely has a value proposition. So with intellectual property, we've touched on the fact that there's different types of intellectual property, and those really go into two parts. Part one, it goes into industrial property. So industrial property being your patents, being your trade secrets, it's something that you can in fact protect. As much as it's a creation of the mind, you would have put it down onto paper, you would have made a product out of it so that it can be protected. The second type that you get is through copyright, so literary works, artistic works, drawings, architectural designs. So what is the basis for protection? We said we're going to discuss two types of protection that's relevant for you today. So the first one is a patent, and the second one we'll look at is trade secret. So patents are protected through various regulatory systems. We have the Paris Convention, there's also the Patent Corporation Treaty, and then we also have the South African Patent Act. So when you want to get a patent, you have to make sure that you are in alignment with the legislation in order for that to be possible. Why do we patent our products? So we need to patent a product so that you have exclusive rights to it. So I asked you the question, is anyone here have their own side hustle? Do you have a product on the market? And the answer was no. But if you did have a product on the market, you would want to be the person that exclusively provides that product, right? And if anybody else was going to sell the product, that you're the main plug. They come back to you to get the product so that the product can then be disseminated. That's exactly what a patent does. A patent affords you the right so that once you have that right, no one else can utilize it without your permission. So it excludes others. It provides you with a monopoly over the product that you're going to produce, right? So that would be in terms of manufacture, exercising the product, producing the product. We'll also look at disposing it and import. What is important as well in the commercialization process and when you're going to patent something is the marketplace. You need to know for that particular product that you want to bring onto the marketplace, which areas, which jurisdictions, which territories would actually adopt what you're going to utilize. Is it China? Is it South Africa? Is it Paris? And then you protect your product in those specific places. So as much as you have a product, you think it's going to work, you need to understand the customer. You need to know what the unique position is, and then you need to know in which areas are you in fact going to protect the product then. So for patent is a very difficult type of intellectual property to get because it requires novelty, absolute novelty. So with researchers, frequently what happens is you want to publish, you want to go to conferences, you want to speak at a braai to your friends who are in the same field as you about your innovation, and that destroys novelty. So if you think that you have something that's new, you think that you have something that you can take to the market, and you wish to exclude others from utilizing what you've come up with, you need to make sure that you patent your product before you publish. And this is something that can run alongside each other. I know for academics, frequently we want to publish. It's part of the KPIs. It's part of finishing the master's, the honors, the undergrad, the PhD. But it can run alongside each other as long as you have a priority date. So that's important to note. So absolute novelty, you cannot disclose anywhere. And then the second part is inventive step. Would someone in your field reasonably be able to come up with the same product? And with inventive step, what's tricky with it is that if you pull from different sources, does it make it inventive? Would someone else have been able to implement the same strategy? If the answer is yes, then you can't get a patent. So novelty and inventive step are critical. And then the third thing that we said, of course, is that it must have utility. It must be something that you can use in the market, and you should be able to make money from it as well. So with patents, it's regulated by the Patent Act, as we've already stated. So I want to emphasize the particular section. So that's section 25. And under section 25, it provides the two key areas. Invention, it must be protected with novelty, and then we also said inventive step. But 25.2 then speaks to what can't be protected. And if you look at 25.2F, it speaks specifically to programs for computers. So you can't protect a program for a computer with a patent. But I'm going to show you at the end of the presentation what is potentially possible with patenting. So we're going to come back to AI, machine learning, blockchain. How can we potentially protect it by circumventing this particular section? So here we go. In terms of protection, we're going to look at what is a technical effect. So in order for you to protect something where you've utilized blockchain, AI, machine learning, you need to demonstrate that there is a particular technical effect. So what does that mean? Technical effect is defined as, we'll leave out all the other parts and we'll come to the sections that's of importance to you: computer efficiency, computer systems, computer storage. So that is included in a technical effect. If we go to the next slide, we look specifically at what they mean by technical effect. So to have a technical effect, it means you have to have an input. There must be a technical input. This technical input must then be processed, and once the technical input has been processed, it provides you with an output. That output is your technical effect. So it is the output that you would protect with a patent. Right? So that's important to note. So let's just go through that part again. So you can protect with a patent, especially in AI or machine learning, but you need to make sure whatever you're utilizing must provide you with an end output. That end output must have a particular technical effect. If there's no technical effect, you can't patent it. If there's a technical effect, if that technical effect is in fact new, it's inventive, then it can be patented. So please note that. Then we're going to go into trade secrets. So if it can't be patented, what's your next option? Your next option is a trade secret. Now, everyone has drank Coke, everyone has had KFC, everyone knows the Nike, just do it. You know, there's various options for protection, but a trade secret looks specifically at keeping the information that you're utilizing a secret. So with KFC, you'll never be able to replicate the taste because nobody else has that particular formulation. Same thing with Coke. That's a trade secret. So you make sure that the trade secret is in fact kept a secret. You have to make sure that if you are disclosing your trade secret to someone, if it's an employee, if it's a student that's working on the product, that there's confidentiality clauses in place so that the trade secret doesn't become into the public domain where it then is no longer a secret. So key thing, trade secret must remain a secret at all times. It must be protected. You must look at confidentiality clauses. It cannot be in the public domain at any time. There's a specific legal framework that needs to be adopted for you to keep your trade secret safe. and then of course you need to protect it, and it must be documented. So if you're not patenting, because the technical effect is not new and it's not inventive, then you go the trade secret route, but you need to make sure that everything is in place so that the trade secret remains a secret. As soon as it's disclosed to the public, that's where it ends. So in terms of the duty for confidentiality, that of course is critical, because if someone discloses your code, if someone discloses how you've come up with that particular algorithm, then it's no longer a secret. So keeping it a secret, making sure it has benefit, and then the general know-how is also a skill that you'd want to protect. And we'll also look at an innocent recipient, and whether if the person is innocently disclosing, does it then affect the trade secret as a whole. So with intellectual property, what we can then see is that we really have to leapfrog. So what that means is that we've looked at the various jurisdictions that you want to protect in. We've looked at why you're protecting it, right? We've looked at the marketplace so that we understand what the importance is. So here you see I've got De Beers. De Beers focuses on diamonds. You'll find most of their patents, most of their trade secrets, anything that's disclosed is relating to diamonds or in the mining industry. So that's their area of expertise. There's Sasol. You can imagine for yourself what sort of research Sasol is doing. So patents are clustered in a specific way for a particular landscape, right? To serve the audience, to serve the people that are going to utilize the product. And so you need to understand how you're going to supply the product, how you're going to enter into the market. Is your patent in fact valid? What is the scope of it? Have you done all of your searches to make sure that there's an inventive step, and looking at the territory so that the marketplace is somewhere where you can then prosper? So, first part of the presentation, we're looking at intellectual property. How can I potentially protect? Why do I want to protect? And what rights does intellectual property provide for me? We then zoomed into patents and trade secrets, because that's most applicable to the area, the domain that you're in. So with research frequently, once you've completed your desktop work, it's very difficult for one to commercialize their products. And then we want to look at why is that? How do we prevent this valley of death, right? So we've said we know that we have promising intellectual property. We've determined this from the research phase. Now, how do we bridge the valley of death so that we can get commercial adoption? There's two key areas. The one is Innovation Acceleration Fund. So what that means is you need capital in order to get your product to the marketplace, and then prototyping support. So with prototyping support, until you've actually looked at whether your product works from a scalability perspective, you'll never know where the glitches are. So prototyping is also critical, so that you know how you're getting it onto the market, what price are you going to price it at, is it scalable, and where the areas of correction might be. So let's look at bridging the gap from innovation to the marketplace. If we go to my right, we see that there's the first part, which looks at validating the market and what is your business case. So what's key there? You can imagine a car, and in that car, we know that petrol's super expensive. You stop at your engine garage to put your petrol so that you reach your end destination. So while we're putting that petrol, the first stop that you have to make is your market analysis. What is the market saying? Who wants to purchase your product? In which areas, which countries can I potentially sell this product in? That is critical for you to look at. Who are my potential competitors? Who can I potentially partner with? Then the next part that you want to look at is defining your commercial pathway. So when you define your commercial pathway, you're looking at who's my customer, how can I get to my customer, how can I segment my customer, and how much revenue do I require? And the third part is the early regulatory readiness. Is there specific compliance tools that need to be complied with prior to you bringing out your product to the market? So if it's a vaccine, you'd have to make sure that it's SAPRA approved, that it's gone through certain trials in order for you to get it to market. So from a compliance perspective, have you covered everything? Then we jump to the second part, which is looking at building and scalability. So in the previous slide, we said we need a prototype, you need a minimal viable product that you're going to test. And once you have that viable product, you test it in the industry so that you know what the potential outcome of the product is going to be. You'll take your notes down if it's having glitches, if it's having problems, where are these problems, what needs to be fixed. Then you move to your next phase where you continue to test in industry but on a larger level, so you're scaling up. And when you're scaling up, you also need to look at investors. Where am I getting my investors from? So you can look at your investors based on jurisdiction, so potential people that you want to partner with. You can look at venture capitalists. You can look at people that are currently in the marketplace as well to see if there's any ecosystem that you can build or partnerships that can be derived. And then the last part is the collaboration model, so that in fact you do bridge this valley and you enter into market readiness. So being a university, we do have the Intellectual Property Regulations Act, the IPR Act, and this act you have to make sure that you are compliant in terms of how you utilize the university funds. So your endpoints there would probably be a spin-out company or a license, but that would be done by the Tech Transfer Office. So key things to note: before, when we looked at validations, it was purely on a lab scale. Now when we're looking at validations, we say, let's take it to the marketplace and see what the potential problems are. Prior to that, when we looked at scalability, we'd scale it up to a lab process and then leave it there. But now we want to scale and pilot in the actual setting that the product is going to be utilized in. We look at funding, so immediate private capital, and then that can be expanded to various different partners, actually leveraging part of your innovation so that it can be then provided into the marketplace. So from your commercial considerations, we said that there's different routes for exit. You can have a spin-off company, you can then engage with a license. There's various types of licenses. You can get an exclusive license or a non-exclusive license. An exclusive license saying, I am going to lend you my product and only you, and revenue that you make from that product will then be shared by the two of us. That's an exclusive license. So it's almost like a rental agreement. You're renting out your product at a specific cost. Then the term and duration of the license is something that you discuss with your partners as well. Are there going to be improvements on the product? So if you've come up with your code has a technical effect. Once you've done that, now you are collaborating with someone in industry, and the person in industry is saying to you, okay, I want to license it, but who is going to own the improvements to the particular product? So that's also a consideration to think of. The recordal of the license, dispute resolution, sub-licensing is I rent the room. Once I've rented the room, I allow my sister or brother to stay in that same room as well. Now you're doing a sub-license. You rented, so that was the license, and then you sub-licensed it to someone else, okay? And then the maintenance of IP, the consideration of royalties, you of course want to make money, it has to have societal impact, and that will also be affected by the territory that you find yourself in. So in closing, with my last slide, I'd like to say that innovation is created where there's a need. So as long as you're solving a particular need, you know that it has utility and application, it does solve societal whims, and you are able to create impact at the same time also making money, then off you go. Thank you. Any questions?
Good morning, Prof. Thanks for the wonderful presentation. So my question is, if during the conceptualization of your product you used AI chatbot, how does that affect the intellectual property? Does it belong to you? Does the company whose AI chatbot you use have claim to the intellectual property? Or can you even claim like a patent to the product if you use a chatbot in the process of conceptualizing the product?
Thank you. So we're regulated by the Patent Act. So you go and check section 25 of that act. It requires anyone that's going to patent something to be an author. As it stands at the moment, AI is not an author. So you physically have to be the author of that particular code or product. So AI, you can't utilize it and say, okay, this is what I'm going to patent, this is what I'm going to utilize. However, with that said, in South Africa, when we look at patents, we don't do a substantive process. Our process is a bit more formative. So what that means is we look at the papers that you're going to be filling out and not the content inside the patent itself. So 2 years ago, there was a patent that went through that was developed by AI. It was then taken to the courts, and they are currently litigating over it. But that patent has since been reversed because AI can't be an owner to a patent.
Good morning, Prof.
I like Prof. Yeah, it's still Doctor, but I like Prof.
So
Yes!
I wanted to ask, if I came up with an idea and an innovation, and then I sell it to somebody else, how does the transferring of ownership work? Like, let's say I patented it, yeah, and then I transferred, like I sold it to somebody else. How does that work?
This one we've had a very long debate with my colleague yesterday while he was having Coke. So I'm going to handle the first part of the question, and I'm going to hand it over to Thomas to speak to assignment because he's quite passionate about that. But so once you've patented it, there's different ways that you can make revenue from it, right? So this is the house. Now the house, maybe you want to rent the house. If you're renting the house, you're going to go via a license. There's different types of licenses. There's an exclusive license, there's a non-exclusive license. An exclusive license, I'm only renting it to my friend next to me, and she must make the money from it, and we'll decide what the percentages of the royalties are going to be. Or if it's a non-exclusive license, I'm renting it to A, B, C, and D, and all of them are going to provide me a particular royalty. That's a rental. Then there's something called assignment, and assignment, I'm going to leave Thomas to speak to assignment. Thank you, Thomas. You see now your discussion from yesterday. Thank you.
Okay, thanks, colleagues. With the assignment, you can assign your patent to someone else, but okay, thank you. Thanks, Bonolo. Yeah, my name is Thomas Ratle. I work with my boss here. Yeah, I'm working there as innovation officer. She's my line manager. So yeah, you can, maybe first of all, I need to start here by saying, when you develop something during the course and scope of your studies, the IP belongs to the university. I don't know if that was touched. But if now the university decide to say they want to assign maybe a certain patent to someone else, to the third party, let's say Vodacom comes and say they are interested on your patent, right? If you don't want to license to them, or they don't want to license but you want to assign that patent to them, you can do that, but you need to also inform NIPMO as their custodian of the legislation that she was talking about. I don't know if I did answer the question. Are you sorted? Are you sorted, or did I confuse you? Eh? Oh, yes.
So if I came up with a business idea in university and it's only related to the course or like the scope of my studies, is that when the university owns my IP, or is it like, please elaborate on that.
If whatever that the IP that emanated from that is during the course and scope of your studies, that IP belongs to the university.
No way.
But you as the creator
You are the
will be acknowledged. And I know Thomas doesn't like that word acknowledged. So if you come up with the innovation, there's a disclosure form that you fill out. It goes to the tech transfer office. So everyone that co-created in terms of developing is on that disclosure form. So you will benefit from the intellectual property, but the percentage of benefit is something that will be calculated relative to your intellectual property policies within the university. So the IPR Act does allow for benefit sharing. So as much as it's owned by the university, everyone will share in the pie, if it makes sense.
So there is a policy here at UJ about the IP.
I can see everyone's hands up.
Good day, Doctor. I just wanted to ask, so right now we're currently busy with like our 4th year projects for final year. So the thing is you have to come up with a project. It can be like a new innovation or whatever. So you're telling me that if, let's say I create something and then a company, maybe a mining company comes and they're like, we're interested in using your project, the university has essentially the say to let the company to use your project, and they'll be the one who will like benefit a lot from it, whereby they'll just decide, maybe they'll give you like a certain percentage of whatever they may get from your creation.
Okay, are you done?
Yes.
Okay, thanks for the question. What normally happens is that let's say when you invent something, right, you need to go and disclose to the ITTO. There is ITTO here. I think it's led by Dr. Hamilton Pidi. I'm not sure if you know them. But let's say now there is some potential client out there who's interested in your technology. That office needs to go and do the negotiation on your behalf. They are saving the best interest of the university and also of the inventor. So if now they decide to say they want to license it out to the to the mining industry or whoever, the mining company, right? Then they will maybe negotiate those licensing that she was talking about, whether it can be exclusive or non-exclusive, or and then they will do that on your behalf. But there is a benefit sharing on the IP policy that state whether you, as whatever the revenue that they are going to realize from that license, right? To say how much does the university take and how much does it come to you.
And the reason why the university is involved is governed by the IPR Act as well as NIPMO. So there's clear regulations in terms of how the monies will be derived, what can be protected, what is outside of the scope. So it's extremely regulated. And the reason why they came up with the act and why we have NIPMO is because we're utilizing public funds, right? So we're utilizing you being here as taxpayers' money. Someone is being taxed for each person that's at an institution. And because you're utilizing taxpayers' money, government has a mandate to say, what have we done with the money? Is there a potential return on the money? So because it's public funds, it has to be regulated.
So when it go out, it's no longer ASNAT's IP, it's UJ's IP. If you see Mercedes-Benz with nice lights, you say, this one is a nice product of Mercedes-Benz. You don't know the person who invented the lights, right? Yes.
So I have two quick questions, right? So the reason that the university gets a stake in what I would consider my intellectual property is because I utilize their resources, which means if I were to develop something, even though I am a student, if I were to develop something with my own resources, it would count as my own. Then that's the first question, like would it count as my own? Then the second one is, you have experience in this. is it safer to develop something under an entity like the university, or do you feel like I should just like freeball it and try to do it on my own? Which one is better in terms of like the protection of the rights of whatever I develop and the patenting? Thank you.
Maybe let me start with the last question. I believe too much in collaboration. If now you invent something as, what's your name? Loazi, right? Maybe Loazi is working for, let's say you're working for Coca-Cola, right? If now we've got Loazi product, let's say it's a new beverage, right? We see it in the fridge. And versus the one that is a Coca-Cola beverage, which one do you think people will run into? Let's say we see Loazi, it's not a Coke, because you'll be, maybe it's a beverage, it's another drink, right? And there is another one that belongs to, that is under Coca-Cola, right? People are more likely to go for Coca-Cola because it's already established itself. It's a brand on its own, right? You don't doubt their brand. But the Loazi one, people will start to think whether do they have medical aid before they can drink your drink, right? So I would prefer you to collaborate with a well-known companies than just to go alone, right? Maybe I'll give my boss to answer the second question.
If I am a student of the university and I develop something like with my own resources, because I'd assume the reason why they'd have a say or stake in it is because it's developed under their supervision, their resources and everything. So if I develop it on my own with my own resources, who does it count as, even though I am a student of the university?
I'm going to take you to case law, very popular case, probably all of you know it. Before we had our WhatsApps, when we didn't have money, you send a please call me. Please call me at the gate. Please call me, I need 10 rand. Please call me, whatever it may be. But the creator of the please call me was sitting and working at Vodacom. Now the question that came into effect there was him coming up with please call me part of the nature and scope of his work? So the background to that, he was there in the office, still a student, still hustling, still trying to make money, and he was trying to contact his girlfriend. So please call me, 10 minutes away. That was how this please call me was created. So was it part of the nature and scope of his work? That's debatable. Did he use the potential skill set that he had acquired from a know-how perspective, from the job that he was doing? Yes, he did, right? Then in addition to that, when he developed the please call me, did he use the university's Wi-Fi? Did he use Vodacom's Wi-Fi? I don't know. Did he use their laptop? Did he do it during work time? So now it comes down to the nature and scope of what his actual work was. So as a student, if you're using the university's Wi-Fi, you're using their laptop, you're using Prof. Nandi's potential know-how, it belongs to the university. If you are doing it completely outside of that, then it's separate. However, I would recommend when you create, that you do co-create with the institution, because it makes it much cheaper for you. One, the institution is not going to take a risk that they cannot back. They're going to de-risk the opportunity that you're going to engage with. They're going to look for potential opportunities for you from an ecosystem perspective. They're going to bring in the MTNs, the ABSAs, the Vodacom, the Swiss, so that you can continue to create. And not only that, from an IP perspective, patenting is expensive. If you patent in South Africa, you need, I think, about 15,000 for a provisional patent. If you're patenting somewhere else, because we said you want to look at the different markets, you want to look at the different territories and jurisdictions, it can go up to 120,000 rands, and that patent must be renewed. Intellectual property doesn't just sit and wait for you to decide that it's going into the market. There's renewal fees. If you're using a patent plus you're using a trademark, you're paying for the fees on that trademark as well. So it's a very expensive exercise. Yeah. Thank you.
Are you sorted? Do you know how Please Call Me was making money? Do you know how? Pardon? Yes. Okay. Anyone who wants to help? How Please Call Me was making money? How is it making money? Because it's not past tense. It's still. There is always a ringing tone there, right? They'll say dial so and so in order to get Mafikizolo. So those people are paying to advertise there. Yeah. The initial intention there was to notify somebody so that that person can call you back. And that is also another revenue, right? Because if now you send Prof. Nandi to say, call me, he's going to call you, right? Which means now Vodacom is getting something out of that. But in that please call, you find that sometimes it says dial 55552 in order for you to get Mafikizolo song or, one of the piano song.
And it's usually a link on the please call message.
Yeah, it can be a link, it can be a certain code to say dial this code. Yeah. And should I ask questions to see if, can you patent colors?
Can you what?
Colors.
What about the new color?
No, I'm talking about the existing one. Let's say now you've got Vodacom, right? Remember Vodacom was using blue, right? And then CLC was using red initially, right? And then later on, I think those colors were not protected. Vodacom started to say Vodacom is red. They protected those colors. So CLC cannot use those colors, those red colors. If you check now, CLC changed to black, I think. Right?
Speaking to distinguishability, what makes your product distinguishable? So sometimes you see Hungry Lion and you see KFC.
Yeah.
When you see KFC, you know that KFC is KFC based on what the logo looks like. So even if someone wants to duplicate that logo, they have to make sure that there's some sort of change. Otherwise, they're infringing somebody's intellectual property. So let's go to Nike, for example. If you have Nike and you have that sign, right, and then you go to town or Marabastad and you see a nice pair that's it's only costing 150 instead of 600, and when you go closer to look at that sign, instead of it saying just do it, it's saying just right. Okay? So you still identify it as Nike, but they've had to make a change, because if they don't make that change, they're infringing someone's intellectual property. It becomes a counterfeit.
With the example of Vodacom, my question is, are they protecting the logo, or are they protecting the color that the logo has in the protection and not being able to duplicate it?
So with trademarks, you can protect a color, you can protect the assimilation of what the logo looks like, so there's various protections afforded too. So, the thing that looks like the apostrophe, you can protect that, you can protect the color, you can protect how it's configured. The configuration as well plays a role.
When I look at the UJ logo, do they also protect it corporately, or
Yes,
is
the
there
UJ
separate?
logo is definitely protected. Here there's a trademark, you're looking at the design, right? You're looking at the colors, you're looking at where UJ is written. So just in that, as much as it's a trademark, there's various subclasses of trademarking, and those subclasses of trademarking will also be protected. Yes.
Okay, I wanted to add something. If you have got a bottle of Coke where you are, if you check there, you find that Coca-Cola, it's written R. There is R, small r, right? Sometimes it can be TM in other bottles, right? That shows that if it's a TM, it means they've applied for registration of that particular. They are trying to protect it. It's still pending. But now, if it's R, it means it's registered, it's protected. No one can use it other than them. So normally, if you check, let's say you've got a bottle like this, right? You can have many IP in this. There can be a design, there can be the trademark, there can be the content inside. She spoke about the trade secret. The content inside is the one that is a trade secret. The formulation, you don't know how did they formulate the Coca-Cola, right? But outside, you can have the trademark that is written R. If you check Coke, is written, there is R there. There is a small R. Coca-Cola, it has got a small R. Right? Yeah.
Okay, so let's say it's after UJ and all that, nah? You have great ideas and you wanna like follow the whole procedure of like getting legal things to like protect your ideas and all that, nah? What are the procedures of you following that, and also the procedure of you finding sponsors to start your own company?
You want to protect your idea by yourself. I think initially I said you need to approach the ITTO. There is an ITTO, yes, led by Dr. Hamilton Pili. You go and disclose to them. They are going to file on your behalf, right?
Yeah. And then if you've left the institution, you're not a UJ student anymore, you're not utilizing UJ content and the nature and scope, you can still patent your product. You can go to an IP attorney, they can assist you. You can go to CIPC, they will also assist you to patent. It is an expensive exercise, so you'd have to look at how you're going to raise those funds, but there are avenues for that. There's also innovation hubs that can assist, and I think at the CETAs as well.
In the case that you are UJ alumni, you will be using UJ resources, right? There's a certain price that you pay for it. Does the university have the same, how can I say? Is it the same when you're still an undergraduate student rather than an alumni who's just using the library, for instance, using the textbooks provided by the university? Do you still fall under that category where everything has to go through the university?
No. So if you are not registered, it's yours.
Even if you use the... Okay.
Unless if you developed it during your studies, you should go and disclose to the office. But if you develop something after your studies, that IP belongs to you.
Is there a way for the
Or
university...
to your employer.
Is the way for the university to prove that this idea was actually from your undergraduate studies, not necessarily now when you are an alumni?
I don't think, I think right now they are trying to get more IPs than focusing on those who have already graduated. They will try to reach you guys. I don't think they will have the capacity to come and check those who have graduated, whether it was, but if you know, university is watching you, you know, so it can always exposes you at some point, because wherever you're going to use it, they might ask you, where does this work come from? And you have to disclose.
So there's a concept around background IP and foreground IP. So let's say you do your honors, and then while you do your honors, you create something, and then you leave and you go and work. If you're going to create something else based on the foundation that have been made. Thank you, Thomas. You'll be able. Oh, okay. You'll be able to see from the disclosure that has been made to the TTO office what you had before, which would be you would decide with the office. The office will negotiate with you. Is this going to be co-owned or licensed? And then what you've improved on. And if you're going to utilize their services in any way in terms of helping you find venture partners or ecosystem, then you can discuss a proportion of what the institution would get. So now this comes down to deal negotiation. What is the best deal at hand and how are we going to roll it out? So everyone will still win at the end.
Good morning. I have a question based on the regulatory body. So, is there anywhere in their laws or whatever cases that they have that restricts them from taking 100% ownership? Can the university decide to not give you anything, and is that against the law or is that acceptable?
Let me get the question right. Are you saying the university can decide not to give you anything?
Yes.
No, it's not allowed. There is a benefit sharing policy on the IP policy. They need to state whether are they giving you 50% of the revenue that they will be generating from your IP, or I don't know what is the split here, but at TUT it's 50-50, right? University take 50%. If now, let's say the IP is generating, or the royalty that they get, it's 100 rand, right? They will take 50% that comes to you, and then they will take 50 rand of it, right?
Okay.
And then in that 50 rand, we take 50% of the 50 rand, which is 25 rand, to your department, right? Where you come from, so that we can encourage people to do further. And then the other one is for renewal that she was talking about, and we are trying to recover the money that we have spent on the IP.
So what do I end up with after?
No, you took, let's say we are getting 100 rand. Yes. We give you 50 rand. Now the remaining 50 rand that comes to the university, we take 25 rand. We give it to your department to say we encourage further further researchers to further IPs that should emanate from that department, right? Okay. In the 25 rand that we are left with, we are trying to recover the money for the loss that we made. Remember when we file a patent, we did not ask you to contribute something. Okay. When we decided to, she said it's a territorial things. If we decide to go to other or to the route of PCT, right, it's a little bit expensive. So we don't normally come to you to say you need to contribute something as an inventor. It's the university that takes all the burdens. And now even for the development, you may find that they consider it maybe as a lower hanging fruit. They decide to take maybe 500,000 to say, let's develop this thing because already there is there is a client who's waiting for these particular things, right? They can take their own funds to develop it, and so that they can license it or it can be ready for the market. Okay. During that process, they don't ask anything from you. You only contributed intellectually to the IP.
All right.
I don't know if I answered.
So I get my part, and my part is not touched. But
your part, it was 100 rand. You took 50 rand.
Yeah, that's it.
And then, if you are not alone in that 50 rand, you are also going to maybe share it amongst the inventors. Okay. Right? If you are 5, you can decide to say you contributed 50%, and the other one contributed maybe less, whatever. So you are going to share it according to the contributions that you made to the IP.
Thank you.
But I just want to add on that, there's a difference between an inventor and an enabler. So as an inventor, you're contributing intellectually, right? An enabler is someone that's following an instruction. So you must be an inventor to benefit from the invention, not an enabler. Some institutions do allow for enablers to benefit based on their policy, and other institutions do not. So difference between inventor and enabler. Yeah.
So inventors are those who contributed intellectually to the IP. If now in the lab there is somebody who's cleaning the lab, they are not contributing intellectually to the project, right? Those are the people that you can just acknowledge to say thank you to so and so, to Mama Man, so and so, because they made your work to be simpler in the lab.
Okay, thank you. So you might have covered this, but I just want some clarity on it. So we are talking about the usage of UJ resources. What exactly are UJ resources? Can you name maybe a few examples on that?
You being here as a UJ resource, because it's taxpayers' money.
Okay. Okay, there is a clause on the IP policy that says during the course and scope of your studies or of your employer if you are a researcher, right? That IP belongs to the employer if you are an employee, right? So if now you are standing here, you are using their Wi-Fi, you are using their space, you are using this building, it belongs to UJ, right? All the resources here, they belongs to T. If now, let's say for an example, it's somebody who comes from outside, they want you to develop something for them, right? You are using UJ resources, right? So there is that commercial research that you can always give to the industry, but you have to do what we call full cost model. That when you charge them, you rate yourself, how much you're worth according to maybe UJ's rates, right? And then with that, then that's how you calculate the full cost. So that if they now come and say they want to take the work, they give you a research problem to say, can you resolve this? Can you solve this for us? And then you are going to do you have to do the calculations. It's called full cost, but I think there is a percentage that they normally put. I think it's 13% to say if now it costs so much, then 13% of that. I don't know how to calculate it, but though you use that full cost model to calculate that.
Okay.
So that whoever, if they feel like they've contributed or they've paid fully for that particular project, you also calculated your time, the electricity that you have been using to solve their problems. It was not only maybe for your hours alone. You calculate everything. That's why they call it full cost. Yeah.
Okay, so follow-up question. So let's say now I have an idea, and then I decide to build. I use my own PC, I use my own Wi-Fi, and let's say I don't. Maybe I stay off-camera RES. I use the resources from the RES. I didn't use any Wi-Fi from UJ. How is UJ able to track which resources did you use there? How does that go about?
Yeah, I think right now UJ it's more interested in those who come and disclose to their office, right? They do it in good faith. And if you want to hide, obviously it's like, maybe it may not be ethical. I don't know how would you interpret it internally to say whether are you hiding it from them?
I'd rather hide.
Or is it, do you feel like you have been fair to UJ? But if you feel like you are fair, you can always hide it to them, right? But like I said, that university has got a way of treating, they call it karma or whatever, I don't know.
Okay, so as long as I don't approach them and ask for their advice, it's my own thing.
Yeah, it's like doing something in your garage. You are not using university facilities, you are not using any resources that belongs to the university.
Perfect.
It belongs to you. But I don't know why many people always, once they wish to do things in isolation. Because for it to get to the market sometime, in most cases, it will take a little bit longer. if not impossible, if not difficult. Because in most cases, if you do something alone, it's not the same as when you do it in a group. Collaboration is the way to go, according to my where I stand. Yeah. I think we're exhausted now.
Thank you. Let's give a round of applause to our presenters today. That was Dr. Kim and Mr. Khatle from TUT. And I honestly hope you took notes. I see some of you did not take notes at all. But if anything, maybe you noted in your subconscious that the things that you were doing today are very important for you. I know mostly it's engineering students, and in terms of creation, you work with your hands, with what it is that you're creating, and it's physical products. But then our first speaker, Prof. Mpegwa, in terms of what she was presenting about data protection and ensuring that what you put into your system is accurate and consistent. Let's say, for example, as an engineering student, you're going to create a weather sensing product that you're going to put outside. It's a physical product, but then that physical product still needs a software that's going to read the information that you're going to get outside. So it in as much as it seems like the presentations were standalones, but they still merge into each other in terms of what you would be creating. And then also what I've taken from the speakers today is that you must co-create and align yourself with popular brands. I know everyone knows Scott Maphuma, I would like to believe, but I know you knew him because of Maphorisa. You know, he didn't come into the industry alone. And that's how he managed to get a lot of time on, to get played on radio. That's how he managed to get into the industry, because he did not come alone. So like Mr. Khatle was saying, collaborate with popular brands, collaborate with people who are already in the industry, because they would be able to guide you, and that thing gives you a level of trust in terms of what it is that you are putting out there to the consumers. And then also one of the things that I noted down in terms of what I learned on my end, which I hope you also learned, it's the market discoverability, which Dr. Kim touched on. And then on Prof. Mpegwa's side, she mentioned that you need to build what the user needs, which is basically the same thing. You're going to go out there and then get your trials in terms of what the markets want. And that's what you need to do. Create what the market wants, not necessarily what you think the market wants. So I hope it was an informative session for each one of you. So yes, I guess let's give ourselves a round of applause for waking up. Because not everybody is here, right? Yeah. Okay, so that comes to the end of our session today. From here, we've got some refreshments for you. We are going to okay. We are going to head to Kopanong to get some refreshments. And then we also have some gifts for our guests. Dr. Kim and Mr. Khatle. Should we? Okay. Okay. Can I have? Okay. Say what he wants. Thank you guys for your time. That's a wrap for today. Thank you.